very important subject. Me. We will see what makes an atom work. Ahead to the 19th century, scientists discovered the atom. That is, they developed theories about the way atoms behave. They still couldn't see us, even with the most powerful optical microscopes. We're so small, the head of a pin contains 100 billion billion of us. In fact, everything in the universe is made of atoms. At last, scientists found the key for unlocking the secrets of the atom. Some very smart fellows experimenting with uranium fired a neutron at its nucleus. The atom split into two smaller atoms, and energy. Now we're getting to the exciting part. Consider the two atoms that are the result of the splitting of a uranium atom. Each has its own binding force, but for some reason, less cosmic glue is needed in the two smaller atoms. A tiny fraction of the binding force is left over after an atom is split. What happens to it? It's released as energy, and this brings us to December 2nd, 1942. For the first time in history, scientists generated energy by splitting atoms. Atomic fission was controlled. A source of abundant energy was discovered inside the atom. When atoms are split, here's what happens. Fission. A single neutron starts a reaction by splitting the uranium atom. Energy is released as heat and radiation, and powerful gamma rays, similar to X-rays. Also, free neutrons are driven out of the atom. If enough uranium atoms are present in what we call a critical mass, the free neutrons split other uranium atoms. And their free neutrons split more atoms. Billions upon billions of atoms each release a little of their binding energy. Under the right conditions of critical mass, there can be a lot of energy released very quickly. A chain reaction. But nuclear energy is no good unless we can contain it and make it work for us. We had to learn how to release the energy slowly and safely. And we did that in one of these, a nuclear reactor. To make electricity, we must start with fuel rods, which contain sufficient uranium-235 to maintain a chain reaction. Energy released from the fission of atoms heats the reactor's water, turning it to steam. This mechanical energy drives turbines to make electricity. The water also serves as a moderator to slow the neutrons. Oddly enough, the slower they move, the better their chances for nuclear fission. Control rods can slow down and stop the reaction by limiting the number of free neutrons flying about. The reactor continues to heat the water, producing steam, until the uranium-235 is used. Soon, the world's supply of recoverable fossil fuel, coal and oil, will be depleted. Then, we will have to rely on the energy from inside the atom to produce our electricity, for our cities and industries. Research scientists continue to look for peaceful applications of nuclear energy. Pioneering research tempered with wisdom will enable us to discover new, safe, useful applications of nuclear technology and to prepare a better world for future generations.